monotonicity here. Secondly, any 2 points, you take any point, say K, L, M, any 2 points can be compared, and that satisfies the property of completeness. You take any 2 points on this XY plane, okay? If supposing I take the point L and M, okay? Supposing I take the point L and M. Now, what can be said about L and M? Which is preferred over which? Can you put it in the chat box? So if I take any 2 points in the XY plane, okay, if they are on different indifference curves, like the case here, L is on a higher indifference curve than M, I can easily say L is preferred over M. If I consider M and N, and I see that M and N are on the same indifference curve, I can say that M is indifferent to N. Okay, so any 2 points I take in the XY plane, they can be compared, and that satisfies the property of completeness, that any two bundles I take in the XY plane, they should be comparable according to the preferences of a consumer. So the indifference curve also helps us in understanding that completeness as a property will be satisfied. Monotonicity, I have said. Completeness, I have also said. Reflexivity is very basic and it is understandable. Any bundle is as good as itself. Here in the indifference curve approach, the bundle will be indifferent to itself. Okay. Transitivity. By looking at this, I can say that K is preferred over L, and I know L is preferred over M. See, K is preferred over L because K is on a higher indifference curve than L. L is preferred over M because L is on a higher indifference curve than M. So by the indifference curve approach, I can also see that K is on a higher indifference curve than M. Therefore, K is also preferred over M. Therefore, transitivity holds as a property. So if I take any 3 points and I notice a relationship between them, K preferred over L, L is preferred over M, K will be preferred over M. So the property of transitivity also holds when it comes to indifference curves. Reflexivity is a very meaningless property to an extent. The property is that any bundle is as good as itself. So I am basically saying that L is as good as itself. That will be satisfied here because L is on the same indifference curve. If I compare L and L, I can say that L is indifferent to L. If I compare the same bundle, L is indifferent to L. Therefore, reflexivity, which says that any bundle is as good as itself. Yes, in this case, we see that L is indifferent to L. Therefore, reflexivity is satisfied. Okay. Last but not the least, strict convexity. How to identify whether strict convexity is satisfied or not? Strict convexity as a property basically told us that averages are preferred over extremes. What it tantamounted to was something like this. C and N, look at this example. C and N are bundles on the same indifference curve. C and N are example of a bundle which are on the same indifference curve. Okay. Any combination of C and N will be preferred over C and N. So any combination of equally preferred bundles, C and N are on the same indifference curves, therefore they are equally preferred. C is indifferent to N. That is why they are equally preferred. So any combination of C and N will be preferred over C and N. So any combination, how do I show what is a combination of C and N? C and N as a combination is the straight line and all the bundles on the straight line. So this curly part, all combinations on this curly line, all combinations on the straight line joining C and N, CN line, all combinations will be preferred over C, which is indifferent to N. This is what strict convexity says. Okay, which holds here. Why is it holding here? You can notice that each point here, supposing this is a point, notice that I will be able to draw indifference curves like this. Now, each indifference curve which is passing through this curved line through this, curly line, all indifference curves passing through this curly line will be preferred over U2 because they are higher. So the line Cn, or all bundles on Cn, lie on a higher indifference curve than the indifference curve of C and N. Therefore, Cn line, all bundles, preferred over C and N. Okay, am I understandable here? So as I said, the Cn line, all the bundles on the line Cn will be preferred over the bundles C and N individually, because the line Cn gives me all the bundles which are higher than the indifference curve on which C and N are lying. Therefore, strict convexity as a property holds. So indifference curve gives us a beautiful picture showing us and satisfying all the preferences and the properties that an economist wanted to satisfy. Okay, so an indifference curve is the answer to all the problems of an economist when it comes to utility functions.